Hi everybody, and welcome to Stoichiometry Notes Part 2. Today we are going to talk about something that is called percent yield. All right, and percent yield is a way of us talking about what's known as error analysis, and that is seeing how close lab data is to the theoretical data. So here we go, a couple important points. The quantities that we calculate using stoichiometry are what we call theoretical. That's what should happen in a perfect world. If everything was perfect, we would get in a lab what we calculate. All right, so they represent what should happen. In real life, all right, the actual or experimental, product obtained is often less than that of the theoretical yield. All right, therefore, we will calculate what's known as the percent yield. So here we go. Percent yield is your experimental amount of product. Why we use the word actual, it means that you can touch it. Okay, so the real experimental product over the theoretical amount. And again, where are we getting that theoretical amount? That's coming from a Stoich problem. All right, so your job is going to be to come up with this theoretical amount and then compare your lab data to it. All right, and it is a percentage, so we're going to multiply that by 100. Okay, so let's see this in an example. All right, so here we go. In a lab, a student burned 0.13 grams of magnesium metal. She measured her product and found that she recovered 0.09 grams of magnesium oxide. What was her percent yield? Well, with any stoichiometry problem, remember we must have a balanced equation. We are burning magnesium. Anytime you burn something, it means you are reacting it with oxygen. All right, and then this is a synthesis problem, one we've seen before, and you are going to get magnesium oxide. Remember, magnesium is +2, oxygen -2. I'm then going to balance this. All right, so I have my balanced equation. Step 2, I'm going to get my theoretical yield. So in a lab, a student burned. She started out with 0.13 grams of magnesium metal. So I want to start out with that same thing. So 0.13 grams of magnesium, okay? She burned and found that she recovered. So this right here, she recovered in the lab. We're going to use that later. That's your lab data. All right, of magnesium oxide. What was her percent yield? So we want to use magnesium oxide as what we are looking for. So we want to go to grams of magnesium oxide. So here we go. This is our stoichiometry problem. Okay. In 1 mole of magnesium, I look at my periodic table and I find that my mass is 24.3. So I have 24.3 grams. I'm now going to use my mole to mole ratio. So moles of magnesium on the bottom, moles of my product on the top, magnesium oxide. All right, and remember we use those coefficients, and each of those has a coefficient of 2. We still write those in there. I know mathematically they're going to divide out, but we do still write those in to show that relationship. And then in 1 mole of magnesium oxide, the mass from the periodic table, all right, is 24.3 plus 16, which gives us 40.3 grams. Okay. All right, we're then going to put that in our calculator, and you're going to find that the student should have gotten about if we're being good about significant figures, I gave you 2, so about 0.22 grams of magnesium oxide. All right, that is the theoretical yield. I want the percent yield. So you're going to take her actual, all right, her lab data, which was 0.09 grams. You're going to divide that by what she should have gotten, which was 0.22 grams. And then we're going to multiply that by 100. All right. And let's see. Okay, let's put that in our calculator and see what we're going to get. So I've got 0.09, all right, divided by 0.22, okay, and I'm going to multiply that by 100, and she got about a 40.9% yield, okay, which tells us that she got about 41% of what she should have gotten in this lab. And that's okay, that happens sometimes in reactions, okay? All right, so let's go on ahead. Let's do one more example together. Okay, and we're going to look right here. In a lab, a student produced 28.7 grams of precipitate, from the reaction of 25 grams of sodium hydroxide and excess copper 2 sulfate. What was the student's percent yield? Okay, so we're given two numbers. You have to figure out which one you want to use. In the lab, a student produced. So right here, this is your lab or experimental. All right, so we're going to wait and use that later. Okay, what did she produce that from? We're going to use her starting point. Okay, so we're going to start with his 25 grams of sodium hydroxide. But before we do that, we need to write that balanced equation. So I have sodium hydroxide, NaOH, plus copper 2 sulfate. Okay, so CuSO4, double replacement. So I'm going to have sodium sulfate plus copper 2 hydroxide. All right, you check those solubility rules and you're going to find that this is your solid. That is your precipitate. Okay, I do need to balance my equation, and I believe by doing a 2 right here, I'm good to go. Okay, so now I'm going to do a stoichiometry problem starting with 25 grams of NaOH, and I want to find what she found. She found the precipitate. This is my precipitate, so I want to end with grams of copper 2 hydroxide. All right, if you want to take a moment and pause, you can try this yourself. All right, I'm going to go on ahead. 1 mole of NaOH. All right, has a mass of 40 grams. That's a 0. All right, I'm now going to do my mole to mole ratio. I have moles of NaOH on the bottom, moles of my precipitate, which is copper 2 hydroxide, on the top. All right, and I'm going to look at my balanced equation. I have 2 moles, a 2 in front of the sodium hydroxide. I have a 1 in front of my copper 2 hydroxide. And then my final step is to change this to grams. 1 mole of copper 2 hydroxide, all right, has a mass of 97.5 grams, again from the periodic table. All right, great. So I'm going to go on ahead and solve for this, and this tells me that she should have gotten about 30.5 grams of copper 2 hydroxide. She didn't. She got 28.7. So to answer the question, because the question was, what's the student's percent yield? I'm going to go 28.7 divided by 30.5. All right. And these are both in grams. Okay. And I'm going to multiply that by 100. And I find that I have a percent yield of, okay, got to put that in my calculator, and I have 28.7 divided by 30.5. All right, multiplied by 100. It's about 94.1% as your final answer there. All right, okay, go on ahead, and you have one more practice, so go ahead, pause the video, please, and start out this one, and I'll read this question for you. When a student reacts 15 grams of magnesium with excess silver nitrate, remember excess means there's plenty of it, the reaction produces silver metal. The teacher anticipates a 75% yield for this reaction. What mass of silver must the student produce to achieve this yield? So go on ahead and write the balanced equation and figure out your theoretical yield for this. Go and do that now, please. All right, so here's our balanced equation for this. Okay, so we've got magnesium, and I am reacting that with silver nitrate to give me magnesium nitrate. This reaction does happen according to the activity series. Magnesium nitrate and silver. Okay, I'm going to start out by figuring out what my theoretical yield is. All right, when a student reacts 15 grams of magnesium, that's going to be my starting off point. And I'm going to figure out how much silver that should produce. 15 grams, I changed it to moles right there. 2 moles over 1, where did I get this? I got this from the balanced equation. I have 2 moles of silver for every 1 mole of magnesium. I'm then going to change from my moles of silver to grams. All right, so if this was a perfect reaction, you should get 133.2 grams of silver. The teacher knows that this is not going to happen. All right, and so the teacher is saying, okay, I'm expecting a 75% yield for this reaction. All right, so what are we going to do to figure out what that is? Well, I'm going to take 75% of my theoretical yield. And to do that, remember a percentage, we're just going to put it back in regular decimal form, 0.75, all right, times 133.2 grams. Okay, and so 0.75 times 133.2, all right, and so that's saying 99.9 grams of silver. So if this student ends up doing this reaction and ends up producing right around 100 grams, that means that she met the teacher's expectations. All right, great. We'll do more practice with this. Have a great day.